Hi, this is Coach Dorf. We're going to now look at problem number 39 from section 4.3. Again, this is a problem that's similar to a homework problem, but it's not a homework problem. And hopefully you can use this to help you develop the thinking and the ideas on how to solve problems that are like this that are in the homework. All right, so in this problem, I'm supposed to sketch the graph of a function. I'm not given the function, but I'm given some properties of the function. So I'm not going to read all these properties, but you can see them on the screen here. So to do this problem, first thing I'm going to do is make a kind of a graph, and I'm going to kind of just put in some values. And we're going to use this to give us an idea of what the function should look like, the graph of the function. And then if it's a little bit off, we can go back and change it. It's okay that if my graph does not look totally perfect the first time, we're just going to use these ideas. All right, so the first idea I see here is that f prime of 5 equals 0. So that means when x is 5, so there's x equals 5, I'm going to have a flat horizontal line for the tangent line. So I'm just going to put a little mark there. This means I have a horizontal tangent line at this point at x equals 5. All right, and then I'm also given that the derivative is less than 0 when x is less than 5. So that means it's going to be going decreasing. So this is f prime is less than 0. And it's increasing. The derivative is greater than 0 when x is greater than 5. So I've got this now. So that kind of gives me an idea. I'm looking at a function that's going to be going down, decreasing, have like the bottom of a cup, and then go back up after 5. All right, now let's look at some other conditions. Here's some conditions about the second derivative. There's this at 2, the second derivative is 0, and at 8, the second derivative is 0. So there's 2, 6, 7, 8, there's 8. So here, that means that I'm going to have a change in the concavity. Doesn't mean I'm going to have a flat horizontal line, but this is going to be a change in concavity. So going between concave up and concave down at x equals 8. And here, going to be a change in concavity at x equals 2. So it's either going to go concave up and then concave down, or concave down and then concave up, most likely. That's what I would think when I have here. Now I'm given that the second derivative is less than 0 when x is less than 2 and x is greater than 8. So let's recall here the second derivatives here. Let's see, if the second derivative is less than 0, that means I have two negatives there, meaning second derivative negative, and that is a frowny face. So meaning concave down. On the other hand, if the second derivative is greater than 0, okay, that means plus, second derivative, 2 pluses, is greater than 0, 2 pluses, and then it's smiley face, and it's concave up. Up there. So again, in this problem, we were told that the second derivative is less than 0 for x less than 2 and greater than 8. So it's going to be concave down. So I'm going to have a concave down type function here. Oops, try that again. Concave down here and a concave down here. Remember, earlier we know that it's decreasing for x less than 5 and increasing for x greater than 5. That's why my concave has to look like these, what I drew in here. All right, and then next, here, we use blue. It's the second derivative is greater than 0 between 2 and 8. So that means it's going to be concave up between 2 and 8. but it's still going down until I get to 5, and then it's going back up. But now that gives me my cup, my concave up. And notice that at x equals 5, I do have that horizontal tangent line. And then the last thing I'm given is that the limits as x goes to infinity and negative infinity, that they both equal 3. So this has a horizontal limit as x goes to infinity of 3, and a horizontal limit here at the horizontal limit equaling 3 there. Okay, let me just rewrite that. Horizontal limit equals 3. Okay, now that I've done all this, let's redraw the graph. I think it'd be helpful. And I'm going to use all this information. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my important points are 2, 5, and 8. And on the y-axis, my important one is I'm going to have this limit, this horizontal limit at 3. Now it doesn't tell me any other value, so I can move what I drew up above, I can move it up and down. So I'm going to use purple here to graph this. I know that at 5, it's going to be my horizontal asymptote. I'm going to have a horizontal tangent line. It's going to be concave up, okay, like this, between 2 and 5. And then it's going to be concave down, increasing, going off limit to infinity, off to 3. And here it's going to be going off to 3 also. And the graph of my function looks like this. Okay, so there's y equals f of x. Now, could your function look a little different than this? Yeah, it could look, it could be, maybe it goes way down here. Maybe it looks like this type of thing. All right, but generally it's going to look kind of like this purple function here, or even like this blue one. Got all the essential information in there. All right, hope that helps you with the homework.